To begin, let's create a new project. Import the plugin as demonstrated in the previous video. Ensure your character already has default weights. It should have an armature modifier in Blender or a skin cluster in Maya. Set the Godot project path. Then assign an asset name. In Blender, select the armature and meshes. In Maya, select the joints and meshes. Click on Export Metadata. Next, we need to export the asset. For Blender, the GLTF format is recommended. For Maya, opt for FBX. If you are using the FBX format in Blender, uncheck Add Leaf Bones to avoid extra bones. Export the asset to the project folder, import data folder, and your asset folder. Remember to check the Selected Objects option. In Godot, you'll see your asset along with the metadata file. Now let's create a node for the scene. Look for Scene Manager and create it. Renaming each node is advised and save the scene periodically. With the Scene Manager selected, click on Create Scene Hierarchy. This action generates essential nodes within the scene. Let's see what these nodes do. World Environment adds visual aspects to the viewport. Vertex Viewer shows selected vertices by the current selector, which can be disabled. Weights Manager exports weights by running various operations, including compute assets to load asset metadata into memory, compute selectors for vertex collision calculations, compute weights that runs all steps in the component manager, and export weights, which creates a file with new weights. Use initial weights loads weights from the asset exported in Blender or Maya before step execution. The export manager presently lacks user functionality but is essential for proper export. Assets are stored in the Asset Manager, and the Component Manager is the container for steps, selectors, and influences. Drag and drop the asset into the Asset Manager. Right-click it and select Make Local to enable editing. In the Asset Manager, click Attach Scripts to Assets to attach necessary scripts to each node, allowing the add-on to identify nodes accurately. Now let's begin character weighting. Add a flood step node to the Component Manager. This step first eliminates influences of selected vertices, then assigning a specified bone with influence of 1. Initially, I'll weigh the entire model to the pelvis bone. Use a standard selector to select all vertices. Assign a collision node shape to it, such as a sphere. Observe the selected vertices via the vertex viewer, upon selecting the selector or collision, which can be disabled. The display mode can be changed to wireframe for better visibility of vertices and the skeleton. Within the step, set the bone name as pelvis. Select the Weights Manager and Compute Assets, Compute Selectors and Compute Weights. An error might occur if you forget to assign the selector. Let's try again. If no error appears in the output, you can now export new weights, stored in the Export Data folder. Upon importing the file in Blender, you can verify that the entire mesh is influenced by the pelvis bone. It's recommended to conclude with a normalize step to ensure all weights are normalized. Assign the previous selector to normalize the entire mesh. Now let's weigh the left arm. I'm going to use another flood step to do a hard weighing, and later I'll use a smooth step. Make sure that the normalize step is the last step. Let's create a standard selector. I'll use a box shape and adjust it. If you select the selector, there's a button to create more shapes if needed. Don't forget to assign the selector and set the bone name. Let's export it. Click on Import, and let's check it. It's not perfect, but it is a good starting point. We can see it more clearly in weight painting mode. I'm going to refine the vertex selection. Now I'm going to use a smooth step. Let's create a selector for the smooth step. Assign the selector. And export it. Here in Blender, we can see that we have a better result with smoother weights. I'm going to do the exact same process for the lower arm. I'll use a flood step and then a smooth step. We could play around with the iterations and strength values to get different results. Let's see the final result. It's not bad, but I'll refine the selector of the flood step. I think that looks better now. Let's see how can we reuse all of these components for the right arm. Reusing components is achievable through grouping and keywords. Create a container node and rename it. Group arm components under the arm container. Implement keywords, allowing substitution of substrings in strings, like bone names. I'll use a keyword for specifying the side, using side, with a value of _L. Modify bone names in steps using the keyword. Duplicate the arm container. Change the side value to _R. Mirror along the x-axis, and the setup for the right arm is set. It looks like everything worked properly. An alternative approach is saving the node hierarchy as an independent node. Create a folder for modules and delete the previous right arm. I'll create a new one using this approach. Save the arm container as a scene by right-clicking and selecting Save Branch as Scene. Instantiate it. Mirror it. And set the side value for the right arm. This approach allows for easy module instantiation and customization. Let's export it and check that everything works properly. Good. This is really useful if the character had more than 2 arms too, because all we had to do is instantiate a new arm module. Also, you could use it as a base for a leg module, for example. Remember that to be able to edit it as a new module, you have to right-click, Make Local. This gives us the opportunity to reuse these weights for a different character that shares some similarity, even if it has a different topology or volumes.